Let's look at this problem. An ant crawls 0.5 meters due east, after which it crawls 0.25 meters due north. How far is the ant relative to where it started, and in what direction with respect to due east? So what we like to do is be very, very organized when we solve these problems. And what helps is to always think in the same way. First, come up with the knowns, then come up with the unknowns, then draw the diagram, and after that, just go and solve the problem. So what I know is that the ant crawls 0.5 meters due east. So since we're given a magnitude and a direction, we have a vector. And I'm going to call this vector A for no better name. And this vector A is 0.50 meters due east. Then the ant crawls 0.25 meters due north. So again, we have a vector. We know that vector B has a magnitude of 0.25 meters and the direction is north. And what we're looking for is the position of the ant with respect to where it started. So we want a displacement of the ant because we're also asked to find the angle. So we want the magnitude of the displacement and also the angle. So here is the diagram. I'm going to draw a coordinate system. Call this east, call this north. That would be west and south. And we know that the ant is going due east first, and then it turns around and goes north. So I called this portion vector A, that portion vector B, and what we're looking for is the distance, the displacement of the ant, how far away it is from where it started. Now, in this particular problem, we notice that we have right angle right here because the ant goes first east and then north. So this is a very simple problem because we're just dealing with a right triangle, so we can use the Pythagorean theorem to solve for vector D, which I didn't label. Here it is. So I will just say that D, and that's the magnitude of D, is going to be the square root of the magnitude of vector A squared plus the magnitude of vector B squared. So that is square root of 0.50 meters quantity squared plus 0.25 meters quantity squared. And when we plug the numbers in, we end up with 0.56 meters for the magnitude of that displacement. But we're also interested in the angle, so the angle is angle theta over here. And we notice that the angle is in a right triangle, so tangent theta would basically be the magnitude of B divided by magnitude of A, which then means that theta is the inverse tangent of the magnitude of vector B divided by the magnitude of vector A. So that is inverse tangent of 0.25 meters divided by 0.50 meters. And when we plug this into our calculator, we get about 27 degrees. So this is the answer that you're looking for. You want the magnitude of the vector and also the direction.